Right, in this question, first thing I notice is the interval is in radians. The upper limit is 2 pi. That is a signal that we're in radians. So straight to the calculator, put it into radians mode. Got the R on the screen. Very, very important. You check for that before you do anything else. Now in this question we have sec squared and we have tan. Use the identity that links together sec and tan. So 1 plus tan squared is sec squared. By using that, I can replace the sec squared with 1 plus tan squared. Make sure you use the right letter. 1 plus tan squared x. I'm going to leave everything else alone. And then multiply out the brackets. It's a quadratic in tan x. So 3 take away 5 is negative 2. It might factorize, it might not. This is another example where it does factorize, so that's probably the quickest way of solving it. You could also solve it using the solver tool on the calculator as well. But if I put a minus 2 there and a plus 1 there, then that works. And we get tan x is 2/3, or tan x is negative 1. Tan x takes all values from minus infinity up to infinity. If you think about the tan graph, which means both of these possibilities will give us solutions. I'm going to sketch the tan graph now to help me get these solutions from 0 to 2 pi. It does have asymptotes, of course, and those asymptotes are when x is, well, in degrees it's 90 degrees, so in radians it's pi over 2. The next one is at 270 degrees, which in radians is 3 pi over 2. Asymptotes on first, and then sketch the graph. So that goes from 0 to 2 pi. It crosses the x-axis at 0, pi, and again at 2 pi. So on the graph I'm going to draw lines y equals 2/3. Let's just put that there. And y equals minus 1. Let's put that one there. I'm not worried about the scale. That just helps me see how many solutions to expect and roughly whereabouts they're going to be. So there's going to be a solution there between 0 and pi over 2, and another one there, and then one there, and one there. So 4 solutions. Make sure the calculator is in radians and do inverse tan of 2/3. I'm going to do that one first. The question says 2 decimal places, and these numbers, yeah, they're going to have values added and subtracted to them, but I'm not going to be multiplying them by anything, so I'm okay to round here. So 0.59 is this one here. Now the tan graph's easier to work with than the sine and cos graphs, because to get the next one I simply need to add on pi. So the next one will be pi plus that. I'm just going to store that number under A in my calculator, and now I'm going to do inverse tan of negative 1, which gives me minus a quarter pi. Although the question says 2 decimal places, this one could have been given as a fraction of pi, but this time I'm going to stick to what the question says. So 2 decimal places minus 0.79. Now of course that is a negative, so we don't want to go put minus 0.79 here because that's clearly not negative. So the calculator has given us the one before that, before the graph started. But once again, the tan graph is dead easy. You just add pi on to get to the next one. So that's all I need to do. Add on pi. And that gives us 3/4 pi, which you can see on the graph fits between a half pi. So it fits between a half pi and 1 pi. As a decimal, that's 2.36. So we've got 2.36 here. I'm going to store that under B. Let's just use recall to check. I've got A and B there. So now I'm going to write down all my answers to 2 decimal places. So X is, I've got 0.59, 2 decimal places. The next one was 2.36. You don't have to write them in order, but I am. The next one was 0.59 plus pi. I stored 0.59 under A. So A plus pi to 2 decimal places, 3.73. And the other one is pi more than the 2.36. The 2.36 I've stored under B. So B plus pi 5.50 to 2 decimal places. So all those are rounded to 2 dp. Remember, you can check those by putting them back into the original equation and seeing if they work.